Welcome all. In the last class, we discussed about the neural networks. So, in the last class, we discussed about introduction to neural networks, where we seen what is a neural network, what is the how neural networks are represented. Then we have also seen where all the neural networks are used. So, that is business applications of neural networks, and then design principles of artificial neural networks. So, with this basic understanding of the neural networks, let us study some more concept of the artificial neural network. In today, we are going to study architecting an artificial neural network, developing an artificial neural network, and advantages and disadvantages of using the artificial neural network. So, coming to architecting an artificial neural network. So, this part deals with which type of the artificial neural network we need to use. So, depending on the task we are performing, whether we are performing classification, regression, clustering or association. So, based on the type of task we are performing, on that we can use the particular type of neural network. So, there are many ways to construct the functioning of an artificial neural network, starting from fairly simple to the more complex structures. The most popular architecture is the feed forward multi-layer perceptron, so which is most commonly called as MLP, and with the back propagation learning algorithm. So, multi-layer feed forward network consists of we know that every neural network contains input layer and the output layer, whereas the multi-layer perceptron contains input layer, hidden layer and the output layer. So, we use back propagation learning algorithm, so in order to make the learning better. There are multiple layers. It means that there are multiple layers of processing elements in the system, and the output of neuron is fed forward, means the output at each layer is being moved to the next layers of the neural network, and the feedback on the prediction is fed back into the neural network for learning to occur. So, once we move in the forward direction, so whatever we get at the output, that is fed back again to the input layer. So, that is what the back propagation algorithm performs. Okay. So, let us see what are the different types of artificial neural networks are present. So, the first is the classification. So, when we want to perform classification, we know that we can use decision trees or support vector machine. We can also use feed forward neural networks, that is multi-layer perceptron can also be used to perform the classification. We can also use radial basis function, that is radial basis function neural network. So, this radial basis function neural network, it is similar to multi-layer perceptron, but the one constraint here is the radial basis function neural network is strictly limited to have exactly one hidden layer. So, then we can also use probabilistic neural networks, that is PNN. So, probabilistic neural networks are scalable alternative to conventional backpropagation neural networks, especially in classification problems. So, they do not need massive forward and backward calculation that is associated with the normal or the ordinary neural networks. Okay, so that is probabilistic neural networks are quite sophisticated than the ordinary neural networks. Then when we want to perform regression analysis, so we can use the linear regression, polynomial regression, such statistical algorithms. Apart from that, we can also use again the artificial neural network. So, that is we can use a feed forward network and radial basis function. Now, when we want to go for clustering, we know that clustering is nothing but a natural grouping of the data objects. So, the clustering can be done, we have algorithm like k-means clustering. So, but we can also perform clustering using artificial neural network. So, the artificial neural network architectures like adaptive resonance theory. So, that is adaptive resonance theory, it is a type of neural network technique, and the basic adaptive resonance theory uses unsupervised learning. We know that clustering is an unsupervised learning, hence ART uses unsupervised learning. So, if we look at the adaptive resonance theory, there are two keywords here, one is adaptive and one is resonance. Adaptive means that they are open to learning, and resonance means that without discarding the old value, so these networks will preserve the old values. So, the ART networks solve the stability plasticity dilemma. So, that is stability means it is a nature of memorizing the learning, and plasticity means they are flexible to gain new information without losing the old information. So, that is this type of neural network technique is used in the clustering. We can also use self-organizing maps. So, self-organizing maps, these are the type of artificial neural networks. So, they are also trained using unsupervised learning. So, since we are dealing with unsupervised learning technique, that is clustering, so the neural network that we use must also be an unsupervised learning technique. To produce the SOM uses an unsupervised learning technique to produce low dimensional discretized representation of input space of training samples called maps, and this is a method to do dimensionality reduction. So, they apply competitive learning rather than error correction learning as applied by backpropagation or the gradient descent algorithms. So, these SOMs are nothing but they are used for dimensionality reductions of the data set, and they can also be they apply competitive learning rather than error correction learning. So, in back propagation we use gradient descent and this back propagation to make sure that error rate is minimized, that is the we use optimization in ordinary neural networks to overcome the error learning, to overcome the errors, but the SOMs use the competitive learning. Then when we want to perform association rule mining, so we can also use a priori algorithm for that, but when we come to the artificial neural network, we need to use the architecture like Hopfield networks. Hopfield networks, they are nothing but a single layered recurrent neural networks in which neurons are entirely connected to one another. So, assume if there are two neurons I and J are available, then there is a connectivity weight Wij lies between them such that they are symmetric, Wij equal to Wji. So, such networks we call them as a Hopfield network. So, these are the different neural network architectures that can be used to perform different data mining tasks, and all the data mining tasks can be performed with different types of artificial neural networks. So, next coming to developing an artificial neural networks. So, most data mining algorithms offer at least the multi-layer perceptron algorithm to implement a neural network. The steps required to build an artificial neural networks are as follows. See, we at least need a MLP, so that is we must at least have 3 layers: input layer, output layer and the hidden layer. So, the following are the steps for developing an artificial neural network. The first step is gathering the data. So, obviously this is the first step of the data mining task. So, whenever we want to perform any mining task, first thing is we need to gather the relevant data. So, in building the ANN also, the first step is gather the data. Now, once we gather the data, so taking the appropriate data is a very prominent task in the data mining. Once we get the data, we divide the data into training data and testing data. So, the training data again is further divided into training data and the validation data. So what do you mean by this training data and the validation data? So this set is used, training data is used to make the network to learn. So that is, this set is used to adjust the weights on the neural network. So approximately we split the given data into 60% as the training data. Then what is validation data? So validation data, it is used to minimize overfitting and verifying accuracy. So whenever there are the some type of values leading to overfitting, then we, in such cases we use validation data to adjust the weights, and this percentage is approximately about to 20%. So training data is made to learn the weights, for learning the network. Validation data is to minimize the overfitting of the network. Then we use testing data. So testing, once the data is being trained and it is also being able to minimize the overfitting, then we test the trained network with the help of the testing data set. So what is testing data? So this data set is used only for testing the final solution in order to confirm the actual predictive power of the network, and this forms approximately 20% of the data set. So altogether 100% of the data set is divided into 60 as the training data, 60% as training set, 20% as validation set, and 20% as the testing set. So this testing data confirms the predictive power of the neural network. Now apart from these three techniques, we have one more most important technique, that is k-fold cross validation. So here we are having a separate testing data, we are making a separate testing data, but whereas in k-fold cross validation, so we divide the data into k equal pieces and learning process is repeated k times with each piece becoming the training set. This process leads to less bias and more accuracy, but it is time consuming. So what happens in k-fold cross validation is, assume I have 4 values. So in the first iteration, so I need to make 4 iterations. In the first iteration, maybe the first value is the testing data and remaining 3 are training data. In the second iteration, the second value is the testing data and remaining first, third and fourth are training data. And in the third iteration, the third value is the testing value and the remaining 1 to 4 are the training data. Then in the fourth iteration, fourth value is the testing data and 1 to 3 are the training data. So in this way every data will become a training as well as the testing data, so hence which gives the more accurate result. But to perform this we need lot of time, so hence it is more time consuming. Next, once we gather the data and divide the training data and testing data and validation data, then next step is to select the network architecture based on the requirement. If we are performing the different type of classification clustering, so based on that we need to select the network architecture. Then once we select the architecture, we need to select the algorithm, so such as multi-layer perceptron or other algorithm. Then once we set the algorithm, we need to set the initial parameters. So we need to set the initial weight, initial bias, and we need to decide which type of transformation function we need to use, whether we want to use ReLU or sigmoid or a linear transformation. So we need to set these parameters. Then we train the artificial neural network with the training data. So then we validate the model with the validation data for any overfitting or minimizing the overfitting and verifying the accuracy. Then once we get the appropriate result, we freeze the weight and other parameters. So once we perform validation, then at that time we will freeze the weights and the other parameters, that is like biases, and then we test the network with the we test the trainer network with the testing data, and then once we are getting the appropriate accurate predictive values, then we deploy the neural network when it is giving the good predictive accuracy. So these are the few steps which we follow when we perform an artificial neural networks. So other neural network architectures might be a probabilistic and self-organizing maps, as we have already seen. So they can be used in the classification of the problems. They can be probabilistic neural network can be used in classification, and SOMs can be used in clustering. So what is a pseudocode for SOM algorithm? So self-organizing map, what it does is, so initially it initializes each node's weight, then present a randomly selected input vector to the lattice, then determine the most winning, that is resembling node, then determine the neighboring node, then adjust winning and neighboring nodes and make them more like the input vector. So then we repeat the steps 2 to 5 until a stopping criterion is reached. So this is how the SOMs will work. Coming to advantages and disadvantages of artificial neural network. So artificial neural networks have a lot of advantages, but they also have some limitation. Now coming to advantages. Artificial neural networks impose very little restriction on their use. They can deal with nonlinear relationships, and they help in finding practical data driven solutions where algorithmic solutions are non-existent or too complicated. So artificial neural networks are uh, very versatile, so they can be applied for any field of interest where we cannot have a appropriate algorithm to find the solution. Then there is no need to program ANN, as they learn from example. So the learning, there is no need of any rule based encoding. So they try to learn on their own. They get better with use without much programming effort. ENN can handle variety of problems including classification, clustering, association and so on, as we have already seen just before. So which type of architectures of ENN are used to perform classification, clustering, association and regression. Then ANNs are tolerant to data quality issues, and they do not restrict the data to follow strict normality or independent assumptions. So even though the data is not too high, is not quality, is of good quality, then also the ANNs can perform the given task. So they are very much tolerant to the data quality issues, even though some of the values are missing or some are outliers. So then they can still give the better results. So ANNs can handle both numerical and categorical variable. So this is very important. So some of the if we go for statistical algorithms like regression, so they work only for the numerical data, whereas if we go for some of the different type of some other algorithms, they may be working for only the categorical variables. But anyway, ANN can be useful for both numerical as well as the categorical variable. So ANNs are much faster than other techniques. So they are much faster than if we look at constructing decision tree for a huge data set. So compared to that, ANNs are faster. ANNs provide better results compared to statistical counterparts once they have been trained enough. So the only thing that is here is once the network is trained properly, so then it can beat all the other techniques. So what are the key disadvantages of the neural network? So they are not easy to interpret or explain or compute. So we cannot easily tell how the weights are being changed. So that is what the one of the limitation. So they are seem to be a black box solutions. So they cannot be clearly explained how they are changing the values of the weights. Then optimal design of ANN is still an art, so it requires expertise and extensive experimentation. So how many layers we need to have in a network? So that depends upon how much expertise we have in that domain. So maybe with the two hidden layers we may get a different set of values, or with even with one hidden layer we may get a more a good result, or how many nodes we need to have in how we need to have in each layer, how many processing elements are to be present in each layer. So it all requires an expertise. So that is one of the difficulty in the artificial neural network. It can be difficult to handle large number of variables, especially the rich nominal attributes with an ANN. So if there are n number of input attributes are present, so then it becomes a bit difficult to train the network. Then at the last, so it takes large data sets to train an artificial neural network. So when we come to the neural network, the data set must be sufficiently large. Otherwise, if we give a very small amount of data, then maybe the network may not be able to learn properly, and we may end up with a less accurate predictions. But if the data set is large, although it is time consuming, but once the network is trained properly, then we can get the better results. So that is the availability of large data is one of the limitation for the artificial neural network. So what what in summary what we can say is, there are many ways to architect the neural network. So it is feed forward MLP, probabilistic, SOM, Hopfield network, then adjacent adaptive resonance theory. So there are so many different neural networks are possible, and these neural networks can handle variety of problem types, and all neural networks need large data set for training. So that is what one of the main important requirement with respect to the neural networks. So that's for the today's class. Thank you.